Hi, welcome to UBC's Master of Engineering Leadership web series. Today we will be focusing on high performance buildings. My name's Ken Zudema and I will be moderating this session. I would just like to remind all those tuning in that this is a live session, so we do want to hear from you. If you are keen to have your questions answered by any of those on our panel today, please make sure you comment in the comments section below. Additionally, if for some reason we are unable to get to your question, we will be responding to everything following the end of this event. But I'd like to start by introducing our panel for today. So we do have the co-directors of our program, Dr. Steve Rogak, and also fellow co-director, Ron Kellett. We're also joined by our current student, Charlie Lancaster. What they're going to do today is to give us a real insight into the program and to answer your specific questions. But I'd like to start with you, Dr. Steve, and also Ron. Can you give us a brief overview of the program?
I'll let Ron start.
Sure. Thanks, Steve. Maybe I can just frame the reason the program exists, and then we can drill into how we've designed the program to respond to that. The program started with a proposition that there's a new type of professional that's needed to participate in the design, construction, engineering, and operation of the built environment to achieve higher performance, mostly centered around sustainability goals. And that the notion of a professional education that enables students coming from different backgrounds within that arena to be able to work together, to become leaders and change agents towards changing the way practice is unfolding out there in the world. And what that means is that we want to teach students to understand the kind of interdisciplinarity and the integration required of professional disciplines to be able to work in that arena, but also how to work together, which is a huge and important part of professional education in this area. So the way the program was designed, which was in collaboration with many professionals who are working in this arena, and what they told us is that we needed to pull together a technical discipline, in this instance mechanical engineering, and an integrative discipline, in this instance architecture, to be able to look at how technical knowledge and qualitative knowledge come together to make really robust and durable solutions towards a higher performing built environment. The particular focus of this high performance buildings program is energy systems. And energy, in a way, is not only a huge and important issue in the built environment, but it's a good proxy for how to tackle a problem that requires many different kinds of expertise. It needs technical knowledge, it needs design knowledge, it needs human context knowledge. There's lots of things that you need to work on. So the program was designed to be able to empower or enable that kind of leadership and change agency in our students. So it combines a kind of an underlay of business and leadership and management capabilities. So the notion there is that students will go out and lead design teams or lead client teams. And then there's two separate pieces, one dealing with mechanical engineering expertise and another dealing with architectural domain expertise. In between are a series of what we call capstone courses, where students work together in small teams to simulate what it would be like to solve an interdisciplinary problem in a professional context. So each of those capstone projects is more of an integrative course that's a collaboration between students and between the two disciplines. I think I'll hand it over to my colleague Steve, who will talk a little bit more about how those classes are configured and what students do in them.
Mm-hmm. Well, I've had an enjoyable time this term teaching essentially thermodynamics and building energy systems, and something that's always interested me in broader mechanical design as well as building design is that there's really no free lunch, and there are always trade-offs that you have to make. And it's actually by understanding how those trade-offs work that you can achieve higher performance. And I think what we've been covering in the term this year is looking at different waves of supplying the energy needs of buildings and how those differ in terms of their energy types that they use, the capital expenses, operating trade-offs, and trade-offs with comfort and air quality. And even though we're maybe not a purely technical program we at the heart of it, we think that the technical understanding is needed to understand the integrated design process. And I don't know, has that come across in class, Charlie?
Definitely, yes. Yeah, thermodynamics and energy systems is one of the biggest courses that you have to.
Yeah, we definitely don't want to spend all the time looking at equations. We've had I think 4 field trips to different places, and we will have somebody knowledgeable in that building in different capacities. So in one building we might have had the mechanical designer who's giving the insights into the building. In another case we had the chief architect for the building talk about the issues involved in designing the building. The real world issues of just dealing with contractors is an important part of the trade-offs, I think. So, and we're going to be carrying that forward into the Capstone projects, as Ron mentioned, where hopefully the technical knowledge gets applied to a real-world case study. So,
actually, if I could amplify that just a little bit, one thing that has affected the way the course or the program has been designed is both Vancouver as a city and the University of British Columbia as a campus are leaders in green building practice. The city is widely known around the world as a center for kind of the state-of-the-art practice, and having access to local professionals and access to exemplary buildings and exemplary projects and things to study outside of the classroom has been a big part of the way we think about the program. So.
Fantastic. I might move over to Charlie now, just to get a bit of an insight into the student perspective. So can you give us an insight into your background and what attracted you to the program?
Okay. Well, as my background, as I'm a mechanical engineer. I'm from Costa Rica, and I worked on a medical device company that is as a facilities engineer. So what I've seen in the field, you have to deal with contractors, building, commissioning, design, and everything. And I start noticing that there are a lot of gaps between the building itself. For example, this manufacturing site, it was a big box, and that's it. They didn't thought about like heat gains or solar gains, all the architectural design portions that you will put into a newly designed high-performance building. And the mechanical stuff you have to start designing after the architects have done with their design. So what this kind of program does, it integrates everything, and you can see the upsides there. Mm-hmm. So I've suffered through bad architect designs, and I suffered by bad mechanical designs because it was not integrated. So the expense and the operations doing that, it was very difficult to achieve high performance in a bad design system. So if you can start from scratch, or you can retrofit a building and do it high performance, that's one of the things that when I saw this program, I said, this is it. This is like the perfect fit for me. So
fantastic. And I understand you were looking at programs all over the world. What made you say, at UBC, high performance buildings, that's the one I want to do? Okay.
During my work time, I also worked on project management. And I've noticed that I wasn't, background as an engineer, I wasn't like well trained for administration or organizational leaderships. So I started working to see a master's. So I saw an MBA could be an option, but I didn't want like fully administration. I want something like a mixture. So I started looking for that, and I saw one program in Switzerland, for example, that it was a mixture between 40% administration, 60% engineering. But it was in Switzerland, and it doesn't have any requirement for undergrads to go all the way for the master's. And then I saw this program that it has a requirement that you have to have actually work experience or field or proven experience, and that add value, because I'm learning as well as much as I'm learning in class. I'm learning a lot from my colleagues, my fellow students, because they have a lot of information, a lot of background that they can teach me. So I'm learning all around the world. I'm learning by the minute in class and outside the class. So that's why I decided this program.
Fantastic. And we do know that our students do require 3 years of practical work experience before coming into this course, which does have an impact on the type of students that do come into the program. But we do have our first question coming through from Jamie. Has the program received any feedback from industry leaders that we could share? And this is probably something that the two of you will probably hear firsthand. Are you able to share some of the feedback that's come back from industry?
I can do the beginning of that, and then you can think a little bit about it. So that feedback has come at several times. The program was co-designed with people from industry. We selected some of the most influential thinkers in this arena from the community, and we brought them together with us for a series of work sessions to design what should we teach a future professional if they wanted to be leaders in the field in which you are operating. And those were people in architecture, engineering, building operations, construction management, etc. So we had a lot of consultation going in. In terms of feedback from, one of the things that we've done is we've hired people who are in those fields to teach the classes. So the modeling class this summer will be taught by one of the best firms in North America that does energy modeling. There's another one on green buildings and regenerative design that will be taught by people who are working at the state of practice in that arena. So we get feedback through ways that are not like surveys. We actually have them in the room with us, and they tell us what they think, and our students are, eyes wide open, and they give us lots of good feedback about what they think they need.
Yeah, so it's really not just industry influenced, it's industry led, isn't it?
I would say it's a co-design thing. I mean, we bring an academic perspective to how do you teach, and industry brings a perspective of what do people need to know to be leaders in this field. So
fantastic.
In the energy systems course, my co-instructor taught about 1/3 of the class. Is a principal in a mechanical contracting company, and so he brings this practical side of how you size equipment and how you actually bid on projects, and the intricacies of the business side of it as well. So I think it's, as Ron says, it's been built into the program, not that it's driven completely by industry, but it's a co-project. And we are getting some already. It's only the first term, but we're getting students that are taking on internships at this point, and that will happen more over the term. Yeah.
Yeah. Actually, I'm one of the.
Okay.
Yeah, I got one internship, so we'll see.
Well,
Can you tell us about your internship?
Okay, there is a program here at UBC that's called the Sustainability Internships Program that they select different students, not only from the MEL program for masters, students all over campus. So they open like 65 programs, and then you have to participate, concourse, and actually win the program. And then it's like 250 hours, paid hours, that you have to actually work in summer, and then present a final report to UBC authorities, and that's it.
So where is your internship?
My internship will be here at UBC. It's the energy analysis of the campus itself. So I have to analyze the history of the energy consumption of all the buildings in the campus. This campus is huge, so I don't know. It's like plus to
500 buildings.
So it's going to be a long internship.
And that kind of feeds into one of our next questions, that UBC has often been described as a living lab. Are you able to expand on that a little bit, Steve?
Yeah, so we have a strong group in the operational side of the campus that is looking into the, I guess I know the people that you'd be working with, Charlie, and I think, well, there's a couple aspects. One is the living lab philosophy, and other is the British Columbia context, where our utility has a strong demand-side management program, and so large organizations in this province can invest in technical staff to help reduce energy consumption. So we have a fairly sophisticated group of people looking at how to tune up buildings and how to continually improve the performance of buildings, which we can tap into in our courses. You know, a lot of buildings are run in a kind of build it and leave it mode, but at UBC we have a continuous improvement approach, so that's something we build into it.
No, actually, I thought that was just great.
Yeah,
Yeah, our students engage in same kinds of questions on the planning and design end as Steve has talked about on the operations end. So there's all kinds of expertise here, as Charles has pointed out. There's 500 buildings. There's always something needs to get done. So there really is it's I wouldn't even say it, laboratory might not be the right word. I think of it more as our studio. It's you know, it's not so much a passive thing. We're out there kind of touching things and trying to impact them.
Cool. We do have a question coming through from Samson. Would this program be suited for experienced professionals already in the industry? The business courses are something that's really appealing to him, but how would the technical courses be able to apply to him?
Well, that's a very good question. Teaching thermodynamics, I was initially worried that some of the experienced mechanical designers might not actually learn anything in my course. But I think there is some value in those courses for the experienced people in brushing up and refining their technical skills, and also learning how to teach their cohort, people from architecture or electrical, learning to work with those people. So for some students, maybe the mechanical courses that are relatively easy, and the architectural courses may be more of a challenge, or the business courses. So I think everybody will come at it with a different background, and the relative difficulty may vary across the courses, but I think overall it's still challenging and useful.
And how have you found it from a student perspective? Because obviously you do have a background in engineering and in industry. How have you found it, the workload and the content?
Regarding the business courses, it has been like a new world for us. And it has given a lot of valuable information. For example, we had this course this term about strategy and innovation. And working in an industry, I've worked 6 years in an industry, and there are concepts that wasn't clear for me when I was working. But now that I saw the course, the administration courses and everything, I can see a clear picture, and it's only one term. We'll see the next terms with the other organizational leadership. That's another business administration course that I'm going to take. And the Sauder Business School is one of the top business schools in the world. So I'm learning a lot from them as well. So I think it's more valuable for us.
Yeah, and how have you found the technical side of things?
And the technical side of things, challenging as well. Even though I'm a mechanical engineer as a background, seeing the integrative process, for example, the architectural standpoint about lighting, for example, that was a new one for me, about how buildings can be moved or designed for passive gain. So it has been as well great experience.
Cool. And was there something that you wanted to add further to
No,
that?
I was just going to ask about Charles' experience taking like the thermodynamics course, and you haven't taken the modeling course yet, but just to kind of say, did it seem like dialing back in terms of your demands on your expertise, or was it enough there that you could see how your expertise fit into a bigger picture or something? Like
Steve mentioned, we had 2 professors, and I saw new things that are being applied in the field. I knew my basics, and the mechanical engineer background helps a lot. I won't lie to that. It helped a lot, but I've learned a lot of things in the thermodynamics and energy systems course. It was a good refreshment as well, and I saw new things that they're applying in the field, in the industry.
Fantastic. We have a next question in from Cole. Cole's an electrical engineer, and he's working in the HVAC industry, specializing in smart buildings and control systems. Is the program going to suit someone like him?
I think so. We have one of my students in the program is from that background, and the mechanical engineering content is more challenging for him than for Charlie. But I think I think it's still important for a controls engineer to understand what it is they're trying to control.
Mm-hmm.
I may not actually have the same technical expectations for somebody with that background. I'd be more interested in stretching Charlie's thermodynamics knowledge in the small group work. I may not expect the same thing for an electrical engineer, but I do expect a certain understanding of energy and the second law of thermodynamics really essential for a controls engineer.
Yeah.
So,
and that kind of brings us into our next question. What is the student profile? So, what does the average student look like?
Well, we're learning who they are at the moment, but I think Charles captured the guts of it. It tends to be people who are coming from a built environment profession, whether it's architecture, civil engineering, mechanical engineering. I didn't know we had an electrical engineer.
Yeah.
And they tend to be coming from either the consulting world, like they're working in those fields, or some of them, at least the ones that we looked at from applications last year, were on the client side, that they would work for developers or municipalities, and they were trying to learn how to manage projects that like on the hiring the right people to do the right thing kind of job. And many, as Charles has already articulated, have had a few years of experience and realized either the limits of what their prior education has been, or they've awakened to a new question that they know that they would like to work more on and are drawn to us or a graduate education program of some type to kind of renew and reinvent themselves a little bit. And we haven't been so committed to the number of years of experience, but we've been really looking for people who, want to do something. They want to work collaboratively across disciplinary boundaries. They want to work on real projects. So when we review applications, we're looking as much for someone who kind of gets that and wants to be good at that, as we are looking for, they might have to have this GPA or this kind of work experience or whatever. We're kind of looking for people who are ready to take on an educational experience like this and be part of something that's bigger than just themselves.
Yeah. And is that something that you're really looking for in the student's letter of intent for when they apply?
I think we're always looking for people who are speaking to what motivates them to learn, and the profile that we've just sketched out isn't everybody, but we're really trying to get a group that will learn from each other and will be part of this larger MEL cohort. And so it's not always the same things that tell you that. Sometimes it'll be a work experience profile, or sometimes it'll be their statement of interest. I really want to do this, or sometimes it'll be their education. So.
And how have you found it, Charlie, working with people from such a wide variety of backgrounds? Have you been able to learn from your fellow class members?
Definitely. In different classes, for example, in the business classes, we tend to not only the high performance buildings students, but other pillars from the same MEL program. And I have been learning about not only about culture. For example, I met a fellow student from Botswana. I've never seen that country. From India, China, and different backgrounds, electrical engineers, controls engineers, architects. I have been learning a lot from architects as well. And it's just integrating. You're learning by the minute, just from your classmates in your classes and everything. So it's a great experience.
Fantastic. Yeah. And we do have our next question coming through from Janani. Our program-specific requirements insist on having an undergraduate degree in engineering or a master's in architecture. Should my bachelor's in architecture degree suffice to apply for this course?
I don't know why we might have said they have to have a master's degree in architecture. If your bachelor's of architecture is a professional degree, it would be appropriate.
Perfect. That's a great question. Hopefully that answers it. Suyog, does the program include parametric designing tools like Grasshopper and Rhinoceros?
The courses do not. You have some space for electives, and depending on when courses that have that content are available, one could take it. I know many of the students in the high performance buildings cohort this year have asked to get into a Revit course that's in architecture. And in architecture, we do teach rhinoceros and grasshopper. My guess is it would be hard to get those to line up with the cohort of courses that are in the MEL. They're not designed to coordinate. But one of the lead faculty members, if you've looked at the website, Adam Rysanek, has done a lot of work with Grasshopper as an essential component of energy modeling and data analysis in the built environment. So one of the things that we hope happens more is that students meet faculty who have that expertise and find other ways than classes to become close to that. Like many of us hire research assistants and we have projects outside, and if someone has a particular interest and it maps well into what the faculty are doing, you might find other ways to explore how rhinoceros and grasshopper and built environment performance might be brought into some sort of synthesis.
So as Charlie said, it really is that constant learning kind of a program. There's never a time where you're passively sitting there. You're always taking something in.
Well, and I think being proactive and finding people who have the expertise that you want, I mean, that's kind of what graduate education is. You're the strength and the liability of it is that you're on your own to find things that are useful and interesting to you, and so you have that opportunity, and faculty like hanging out with smart, motivated graduate students, but you have to find them and you have to connect with them. So.
Yeah, and adding to that point as well, they give us as well, the administration, you give us a bunch of tools of extracurricular activities about conference, for example. The Globe Forum was one of those. Next time is going to be the Net Zero conference is going to be held in Los Angeles. So the administration is constantly bombarding us with, sorry, but it's true. They're giving us a bunch of tools, extracurricular activities that you can actually go and pursue them. So it's learning by the minute.
And the Globe conference you mentioned, is that something that you took part in as part of the course, or?
It wasn't part of the course, but the administration helped us to get in, and it was a conference held worldwide from all the leaders in the world on sustainability. So getting that experience, the UBC opened the doors for students to go to that conference, and we actually met a lot of people. We saw the latest and the greatest technologies in the worldwide towards sustainability. So getting that experience, it's delightful. It's amazing.
Fantastic.
So, thank you for that.
We now have our next question in. Does this course differ from clean engineering, from our clean energy engineering?
Yeah. I have a really simple version of that. High performance building focuses on the demand side of that, and clean energy engineering focuses on the supply side. Obviously they overlap, but our distinctive piece of that is that we try to understand what energy do buildings need to be high performance, and clean energy works on where does it come from and how do you get it there with the most positive impact for society and for the environment. So.
Yeah, and I do understand that a lot of the students across both cohorts do interact with one another, and there's been a few entrepreneurial ventures started out of that.
Have we got our first startup yet?
I think we did have a talk the other day, and there was a few students who were on the way. I wanted to ask you as well, Charlie. We mentioned how this is a 1-year intensive master's program, and that was part of the reason that you chose the course in the first place.
True.
What is life like on a day-to-day basis?
It's interesting. First, you have to check your email to see if you have any news from the administration. Check the UBC blogs. The professors gave additional information in the UBC blogs, not only from the course itself, but additional information that is very valuable. So you get news, you get best practices, and then you go to class. And then after class, you got homework, you got work to do with fellow classmates, coordinate meetings, projects, and after that, you have to eat and sleep in some time there, and that's it. So, yeah.
Yeah,
That's
so
about it.
how are you managing the study-life balance? So we do have a number of students who do ask us, is it possible to work while we're doing this program?
Okay.
What's been your experience?
Okay, if you want to take full advantage of this experience, you should not be working and studying right now. It's the extracurricular activities that the program is showing you. You have to take advantage of that because it's once in a lifetime opportunity. It's 1 year, and you have to take all the opportunities that everybody gets you. And then you got a nice workload of the curricular activities. So that balancing that, and as well the program and the fellow classmates tends to do organizations and, okay, let's go for a bike ride to see the cherry blossoms, for example. So that's quite a nice balance. You can hang out with your classmates and continue learning from their experience as well. So that's about it.
Yeah, very
Yeah.
cool. We have our next question coming through. Has a part-time option been considered for this program?
No, for the reasons that Charlie mentioned.
Yeah.
Yeah, it is an intensive program, and in order to get through in 1 year, it's already so much to take in. So taking it out and moving it part-time just doesn't make sense at this point.
I think that it's possible for people to take some of the course components, standalone. But I think, as I think Charlie's mentioned, that being part of the cohort is an extremely important part of the experience.
The next question I wanted to ask is just regards to the co-op. Sorry, not the co-op, the Capstone project. So we spoke very briefly about it at the start. Are you able to give us some insight into what projects students have done in the past?
Well, this is the first year.
Oh,
Brand new.
So I can, but this program, in a sense, came out of a former research-based sustainable building science program where we had a capstone course, and also to some extent out of clean energy, which is an older program. And it used to be that many of the people in that cohort were interested in buildings, so they would do capstone projects related to buildings. And so I can say a little bit about some of those past things. In the past, students would look at, for example, energy consumption of a particular building and evaluate options for reducing energy consumption, changing the way they operated the ventilation system, or changing the equipment used. I know that the clean energy students a few years ago, a graduate from that program, looked at green walls in SIRS and around BC. That person actually has gone on to be the local person involved in the WELL building standard. So that was the clean energy program, but that was a person who I think would have done the high performance building program had it existed at the time. I don't know, do you want to add?
Well, just that we have 2 capstones, and sort of it's a misnomer, I guess, if they're capstones. You're not supposed to have 2 of them. But the idea is that this synthesis of knowledge in the purpose of solving a problem is really central to the learning experience. So in architecture education, we use this pedagogy around design studios, and that's where you take knowledge from your technical classes and from your other classes and you integrate them. So there's 2 of these capstone projects. The first one kind of just more or less takes what you learned in your first semester and applies it to a retrofit problem. So the students will study a building on campus that's about to be upgraded, and they'll be doing, as Steve has recommended or as mentioned, they will be kind of proposing alternative ways to meet the performance standard that's expected of the campus, but there's 3 or 4 ways to get to that place, and the trade-offs are important. And then the second one will be a somewhat more open-ended one where students will propose a more new system that perhaps elevates the innovation component to it.
Fantastic. We do have our next question through. Can we name a few of the softwares that will be taught within the program?
Well, within the energy systems course, so far students have been using a very simple load program, Taco Load. It's not an energy modeling course or major platform. I expect that in the energy modeling course there'll be using eQuest, which is a very simple model again, but we want something that will get this broad cohort to some kind of proficiency as fast as possible. In the capstones, there's an option for teams to take on whatever tool is appropriate and depending on the expertise of the team. So we expect if there is somebody, if there's a team that has some experienced mechanical people and they're interested in something like Grasshopper, then they could take that on in that course. But we're really not we're not driven by the software platforms in this course. I think it's fair to say.
Yeah, actually, I mean, I would underline that. I mean, same thing's true in the way we teach architecture. Is that we do teach software, but our point is to teach students to ask good questions and be able to answer them appropriately. And the software was going to be different 5 years from now, so we don't kind of invest them in one particular platform, but rather how to use software to answer complex questions so that they can make good choices on their own. So
that makes sense. And is there anything that you've particularly been using, not just what's been taught in classroom, but from your own experience that you've been able to bring across?
Yeah, I would say the theory behind the softwares that everybody was mentioning, trying to understand something. For example, you can actually work with a software, but knowing the basics and knowing the equations and knowing the theory, knowing the thermodynamics behind it. I used, basically design, AutoCAD, Inventor. That has helping me a little bit on the design portion of it, but it's not like the gist of the courses. We're learning beforehand the theory that it's behind all those softwares. So that's it.
Yep, that makes sense. We have our next question coming through. How many students are typically accepted each year? I know that we do have a limit to our student numbers. And how big is our cohort size this year?
our cohort is smaller than we had hoped for a cohort of 12, and I think it's at 6.
Mhm.
And our target is something closer to 20. But we're building a program and we're building a brand, I guess, for lack of a better word. And we've been trying to get the right students and work with them. So the cohort will be bigger next year, but we're not turning it into 40 or something like that. This notion about projects and being able to go do site visits is really driving a certain understanding of how big a cohort could be effective. And this discussion that Charles has shared with us about to learn from your colleagues, you have to know them, and it can't be too big.
Yeah, that makes perfect sense. And we are in our first year of the program, so having a cohort of 6 very specific type of students. How have you found just their ability to engage in the course?
I haven't taught them, but perhaps Steve.
I think I've gotten through a lot less material than I originally expected, mostly because the class is very talkative and we go off onto tangents on issues. The civil engineer talks about the difficulty of inserting the pipes in the slab, for example, and we have slide discussions about that. And sometimes it's necessary to spend a little bit more time on a topic to explain it to the architect, for example. I've been really actually very thankful that it's been a small cohort so that we could adapt as we go along and have these discussions. And again, the balance in the cohort has been really nice in terms of mechanical, civil, architecture, electrical.
Yeah.
I think I strayed away from your question there.
Well, I would. It's on cohort size. I think. I would say that at least on the architecture course side, is that we've made the courses so that students in our master's program in architecture can be in them too, and so we think just this same learning that goes across within the cohort, that being in a room full of students who look at a problem completely differently is good for the class. So the architecture versions of these classes have more students in them than just the cohort. So,
and I believe that's the same with the leadership courses as well, is that you work with students across all the different streams?
Exactly. Well, we got one course in HBB that it's only architectural masters students, and high performance people. It's green building. So green buildings. That's the name of the course, and yeah, actually you learn a lot of people doing only a master's in architecture. We had to do analysis of a building that it's already here on site. We have to do an energy level 1 performance. So the architects learn a lot of the engineering material, and we learn a lot of the architectural stuff. So that cross learning experience, it has been great so far.
We have our next question coming through. We mentioned startups and interesting Capstone projects. Can we touch on some of the highlights, some of the really innovative solutions we cover in our coursework?
Well, I guess it depends on where you're targeting the question of innovation. So if you kind of think of the delivery of a high-performance building as a vertically integrated process where you have to decide to build a high-performance building, and you have to have the regulations and the policies in place to enable that, and you have to have the design expertise to design it, and the engineering expertise to engineer it, and the construction expertise to make it, and operating expertise to run it the right way. I think that the students in the course discover innovation might happen at a policy level, as well as at an engineering or a construction or a design level. So we're trying to help our students understand what the whole kind of vertically integrated process is and look for places to intervene in innovative ways. So the green buildings practice course that Charles was just speaking about is really more about policy and regulation. And the campus is an interesting case in point, because one of the big triggers to being innovative was to create the regulatory and policy environment within which innovation can be cultivated. So in that sense, you might discover that an innovation is just putting the right policy or the right building standard in place, or in some cases it might be the way you deliver heat to a building. And so the university again has some projects where we've tried to figure out how to innovate at the scale of supply, because that enables the demand side to have different options.
On the technical side, a few years ago in the previous version of the Capstone course, a couple of students came up with the idea of determining building occupancy from the wireless connections. And so that was an idea that was taken to heart by the campus energy people, and they helped the students develop the prototypes so that the UBC building control systems will know how many students are in the classroom at a particular time from the wireless connections, and then the HVAC system is operating accordingly, so ventilation can be ramped up or cut down to save energy. And so that's now a startup business that I know Charlie saw them at Globe.
Exactly.
And it came out of UBC Capstone projects previously, or out of the sustainable building science program. So
yeah. So if you got like an innovative idea doing your master's, there is another thing that the administration gave us, is a lean launchpad that you can actually start with a great idea, and then actually they can help you all the way through doing a startup of your own. So the tools are there. You just have to use them.
Fantastic.
But there are a lot of tools.
Wonderful. Well, we have actually run out of time. I know there are a few more questions coming through. Please be assured that whilst we unfortunately have not been able to get to all of the questions today, we will be responding to any of your comments posted post the end of this event. But I would like to thank our panel today for all their insights and all their discussion. I know I've learned a lot, and I'm sure our audience has as well. For all those who do live in the Vancouver region, please make sure you visit us at our open house on May 10th at Robson Square. That's a chance to come and meet with the directors in person, meet with current students, and ask all those questions you want answers to face-to-face. So check that out on our website, but it's Robson Square, May 10th. Thank you so much for your time, and please tune back in to hear any answers that we may have missed. Thanks very much.